Why has iOS become one of the most influential operating systems in the world? Let's explore how Apple's mobile platform revolutionized the way we interact with technology and set new standards for the entire industry. The evolution of iOS from iPhone OS to global mobile powerhouse. iOS began as a Unix-based operating system derived from macOS, formerly OS X, utilizing a modified Darwin kernel with components like core animation and WebKit that were optimized for mobile hardware constraints. The initial iPhone OS 1.0 featured a revolutionary multi-touch interface implemented through a capacitive touchscreen and sophisticated gesture recognition algorithms, but lacked fundamental capabilities like multitasking due to RAM limitations, 128-body, and battery conservation requirements. The introduction of the App Store with iPhone OS 2.0 represented not just a marketplace but a comprehensive development ecosystem with the Cocoa Touch framework, which abstracted complex UI interactions through APIs like UIKit while maintaining strict sandboxing for security. iOS 4's multitasking implementation was technically a compromise, offering 7 specific background services rather than true multitasking, preserving battery life while enabling key functionality like audio playback, location tracking, and task completion. The iOS 7 redesign wasn't merely aesthetic. It introduced a physics-based UI with UIKit dynamics, allowing developers to implement realistic motion effects through spring, gravity, collision, and attachment behaviors that responded to user interaction. Apple's privacy architecture evolved from simple permission dialogues to a sophisticated system of differential privacy, on-device processing, and app transport security, enforcing HTTPS connections and implementing content blockers in WebKit to prevent cross-site tracking. ARKit represented a technical breakthrough by combining visual inertial odometry with scene understanding, merging camera sensor data with core motion input to track position without GPS, while using machine learning to identify planes, objects, and lighting conditions. The Swift programming language, introduced in 2014, fundamentally changed iOS development by offering type inference, optionals, and value types, while maintaining interoperability with existing Objective-C codebases through bridging headers. iOS's memory management evolved from manual reference counting to automatic reference counting, ARC, and now incorporates advanced techniques like memory compression, which reduces memory footprint by compressing unused pages rather than writing them to disk. The neural engine, introduced with the A11 Bionic chip, enabled on-device machine learning through a dedicated processor optimized for matrix multiplication operations, allowing frameworks like Core ML to run sophisticated models without cloud connectivity. Swift UI and Combine, introduced in iOS 13, represented a paradigm shift toward declarative and reactive programming, replacing imperative UIKit patterns with a functional approach to state management and data flow. The App Tracking Transparency Framework implements a technical barrier to fingerprinting by restricting access to the device's identifier for advertisers, IDFA, and employing private click measurement to provide conversion data without revealing individual user behavior. iOS security architecture implements a chain of trust from the Secure Enclave coprocessor through the boot process, with each stage verifying the cryptographic signature of the next before execution, preventing modified system software from running. The evolution of iOS networking stack progressed from basic HTTP requests to URL session with background transfer capabilities, and now incorporates network framework with support for modern protocols like HTTP per 2, TLS 1.3, and QUIC. Apple's Metal Graphics API, which replaced OpenGL-ES, provides near-direct access to the GPU through a low-overhead architecture that reduces CPU usage and enables advanced rendering techniques previously impossible on mobile hardware. Key takeaway. 1. iOS has evolved from a simple phone operating system to a sophisticated ecosystem powering over 1 billion devices worldwide, maintaining its core philosophy while continuously adapting to new technologies. Key takeaway 2. The App Store fundamentally transformed mobile computing, creating an entirely new digital economy, and turning smartphones into truly personal devices that could be customized through third-party applications. Key takeaway. 3. Apple's design philosophy shifted dramatically with iOS 7's minimalist redesign, influencing the entire tech industry and establishing new visual standards for mobile interfaces. Key takeaway 4. Privacy has become a cornerstone of iOS, with each version adding more protections and transparency around data collection, setting new standards for the industry. Key takeaway 5. Throughout its evolution, iOS has maintained a delicate balance between innovation and familiarity, often adopting features later than competitors, but implementing them with characteristic polish and integration. Thank you for watching our exploration of iOS evolution. From its revolutionary beginnings to becoming a sophisticated ecosystem powering billions of devices worldwide, iOS continues to shape the future of mobile technology while maintaining its core philosophy of simplicity and user experience.